All new fluorescent ballasts manufactured in the United States are required to have thermal protection. This is a safety feature designed to prevent the ballast from overheating, which can potentially lead to a fire. Old fluorescent ballasts may or may not have thermal protection. The requirement for thermal protection applies to new ballasts manufactured after a specific date. Class P ballasts are a type of fluorescent ballast designed for installation inside a luminaire, which is a light fixture. Class P ballasts don't have thermal protection built into the ballast itself. Instead, they rely on the luminaire to provide thermal protection. To determine if a fluorescent ballast is thermally protected, there are specific markings to look for. Firstly, a T rating indicates that the ballast has thermal protection. Secondly, a Class P marking indicates that the ballast isn't thermally protected and must be installed in a luminaire that offers thermal protection. For safety reasons, it is always best to use fluorescent ballasts with thermal protection. When replacing old ballasts, it's recommended to choose new ballasts that have built-in thermal protection. Understanding these distinctions is crucial for ensuring safety and compliance with electrical standards when working with fluorescent lighting systems. Choosing the correct ballast not only ensures proper operation of the lighting system, but it also minimizes the risk of overheating and potential fire hazards. Always prioritize safety when selecting and installing fluorescent ballasts, and consult with a qualified electrician if you have any doubts or concerns about the appropriate type of ballast for a specific application. It's important to remember that electrical codes and regulations can vary depending on the location, so it's essential to comply with all applicable requirements to ensure a safe and reliable lighting system. It's a good practice to check the manufacturer's specifications and product documentation to verify whether a ballast has thermal protection, especially when dealing with older or less common types of ballasts. When selecting a replacement ballast, consider the specific requirements of the lighting fixture and the environment in which it will be installed. Factors such as ambient temperature, humidity, and ventilation can affect the performance and safety of the ballast. It's also crucial to ensure that the replacement ballast is compatible with the existing wiring and electrical system. Installing an incompatible ballast can lead to malfunctions, damage to the lighting fixture, or even electrical hazards. If you're unsure about the compatibility of a ballast, consult with a qualified electrician or lighting specialist for guidance. Another important aspect to consider is the energy efficiency of the ballast. Newer ballasts often incorporate energy-saving technologies that can reduce electricity consumption and lower operating costs. When replacing old ballasts, consider upgrading to energy-efficient models to minimize energy waste and promote sustainability. Energy-efficient ballasts can also generate less heat, which can further reduce the risk of overheating and improve the overall performance of the lighting system. In addition to thermal protection, some ballasts may have other safety features, such as overvoltage protection, short-circuit protection, and end-of-life protection. These features can help prevent damage to the ballast and the lighting fixture, as well as protect against electrical hazards. When selecting a ballast, it's always a good idea to choose one with multiple safety features to ensure maximum protection. Proper installation of the ballast is also crucial for ensuring its safe and reliable operation. Follow the manufacturer's instructions carefully and make sure to use appropriate wiring techniques and connectors. Avoid overloading the ballast or connecting it to an incompatible power source. If you're not comfortable installing the ballast yourself, hire a qualified electrician to do the job. Regular maintenance of the lighting system can also help prevent ballast failures and other electrical problems. Inspect the ballast periodically for signs of damage such as cracks, leaks, or discoloration. Replace any damaged ballast promptly to prevent potential hazards. Keep the lighting fixtures clean and free of dust and debris to ensure proper ventilation and prevent overheating. By following these guidelines, you can ensure that your fluorescent lighting system is safe, efficient, and reliable. Remember to prioritize safety at all times and consult with a qualified electrician if you have any questions or concerns. The information provided is for general guidance only and should not be considered a substitute for professional electrical advice. It is important to consult with a qualified electrician or lighting specialist for specific recommendations and guidance related to your particular lighting system and electrical requirements. Different types of fluorescent lamps may require specific types of ballast, so it's essential to choose a ballast that is compatible with the lamps being used. Using an incompatible ballast can result in poor performance, lamp failure, or even electrical hazards. Check the lamp specifications and the ballast specifications carefully to ensure compatibility. Some ballasts are designed to operate multiple lamps, while others are designed for single lamp operation. Make sure to choose a ballast that is appropriate for the number of lamps being used in the lighting fixture. Overloading a ballast can cause it to overheat and fail, while using a ballast that is too small for the number of lamps can result in poor performance and lamp flicker. The voltage rating of the ballast must also match the voltage of the electrical system. Using a ballast with an incorrect voltage rating can cause it to fail or even create a fire hazard. Always verify the voltage rating of the ballast before installing it. The ambient temperature in the area where the ballast is installed can also affect its performance and lifespan. Ballasts are typically rated for a specific operating temperature range, and exceeding this range can cause them to overheat and fail prematurely. If the ballast is installed in a hot or poorly ventilated area, consider using a ballast with a high temperature rating. The National Electrical Code, or NEC, provides guidelines for the safe installation of electrical equipment, including fluorescent ballasts. Follow the NEC requirements carefully to ensure that the lighting system is installed in compliance with safety standards. The NEC addresses issues such as wiring methods, overcurrent protection, and grounding. Compliance with the NEC is essential for preventing electrical hazards and ensuring the safety of occupants. When replacing ballasts, consider the disposal of the old ballasts. Some ballasts contain hazardous materials, such as mercury, and must be disposed of properly to prevent environmental contamination. Check with your local waste management agency for information on proper disposal methods. Recycling old ballasts is often the best option, as it allows the materials to be recovered and reused. Energy-efficient ballasts can help reduce the overall energy consumption of a building, which can lead to significant cost savings over time. Consider upgrading to energy-efficient ballasts throughout your facility to minimize your environmental impact and lower your utility bills. Energy-efficient ballasts also tend to have a longer lifespan, which can reduce maintenance costs. Proper grounding of the lighting system is essential for preventing electrical shock hazards. Make sure that the ballasts and lighting fixtures are properly grounded in accordance with the NEC requirements. A properly grounded system provides a path for fault current to flow back to the source, which can trip a circuit breaker or ground fault circuit interrupter, or GFCI, and prevent electrical shock. Regular inspection and testing of the grounding system can help ensure that it is functioning properly. Surge protection devices can help protect ballasts and other electrical equipment from damage caused by voltage surges. Voltage surges can occur due to lightning strikes, utility switching, or other electrical disturbances. Surge protection devices divert the excess voltage away from the equipment, preventing damage. Consider installing surge protection devices on circuits that supply power to sensitive electronic equipment. Proper ventilation around the ballasts is essential for preventing overheating. Make sure that the ballasts are not blocked by insulation or other materials that could restrict airflow. Adequate ventilation helps dissipate heat and keep the ballasts operating within their safe temperature range. Overheating can shorten the lifespan of the ballasts and increase the risk of failure. When selecting a ballast, consider the warranty offered by the manufacturer. A longer warranty period indicates that the manufacturer has confidence in the quality and reliability of the product. Read the warranty terms and conditions carefully to understand the coverage and any limitations. Keep a record of the ballast purchase date and warranty information in case you need to make a claim in the future. Some ballasts are designed to be dimmable, allowing you to adjust the light output to suit your needs. Dimmable ballasts can help save energy and create a more comfortable lighting environment. However, it's important to use a compatible dimmer switch that is specifically designed for use with dimmable ballasts. Using an incompatible dimmer switch can damage the ballast or cause it to malfunction. LED lighting is an increasingly popular alternative to fluorescent lighting. LED lamps are more energy efficient and have a longer lifespan than fluorescent lamps. LED lighting systems also offer greater flexibility in terms of design and control. If you're considering replacing your fluorescent lighting system, it may be worth exploring the option of switching to LED lighting. LED lamps do not require ballast, which eliminates the need for ballast maintenance and replacement. When working with electrical equipment, it's important to follow all safety precautions to prevent electrical shock and other hazards. Wear appropriate personal protective equipment, such as safety glasses and insulated gloves, to energize the circuit before working on any electrical components. If you're not comfortable working with electricity, hire a qualified electrician to do the job. Always double-check your work to ensure that all connections are secure and that all safety devices are functioning properly. Electrical safety should always be your top priority. Class P ballasts, as mentioned earlier, rely on the luminaire for thermal protection. This means that the fixture itself is designed to dissipate heat and prevent the ballast from overheating. However, it's important to ensure that the luminaire is properly installed and maintained to ensure that it provides adequate thermal protection. Avoid blocking the ventilation openings in the luminaire, and keep it clean and free of dust and debris. The color rendering index, or CRI, of the fluorescent lamps can affect the appearance of colors in the illuminated space. Lamps with a higher CRI provide more accurate color rendering, which can be important in applications where color perception is critical. When selecting fluorescent lamps, consider the CRI rating to ensure that the lamps provide the desired color appearance. Some fluorescent lamps are designed for specific applications, such as plant growth or aquarium lighting. These lamps emit a specific spectrum of light that is beneficial for the intended application. If you're using fluorescent lamps for a specialized purpose, make sure to choose lamps that are specifically designed for that purpose. The lifetime of a fluorescent ballast can vary depending on the type of ballast, the operating conditions, and the quality of the components. High-quality ballasts typically have a longer lifespan than lower-quality ballasts. Regular maintenance and proper installation can also help extend the lifespan of a ballast. It's a good practice to keep a record of the ballast replacement dates to track their performance and plan for future replacements. The harmonic distortion produced by a fluorescent ballast can affect the power quality of the electrical system. High harmonic distortion can cause problems with other electrical equipment and increase energy losses. Energy-efficient ballasts typically have lower harmonic distortion than older ballasts. If you're concerned about harmonic distortion, consider using energy-efficient ballasts with low harmonic distortion ratings. The inrush current of a fluorescent ballast can be several times higher than its normal operating current. This inrush current can cause problems with circuit breakers and other electrical equipment. Using soft-start ballasts can help reduce the inrush current and prevent these problems. Soft-start ballasts gradually increase the current to the lamps, reducing the stress on the electrical system. The power factor of a fluorescent ballast is a measure of how efficiently it uses electrical power. A ballast with a high power factor uses power more efficiently than a ballast with a low power factor. Energy-efficient ballasts typically have a higher power factor than older ballasts. Improving the power factor of your lighting system can help reduce energy losses and lower your utility bills. The radio frequency interference, or RFI, produced by a fluorescent ballast can interfere with other electronic devices. Some ballasts are designed to minimize RFI emissions. If you are concerned about RFI, consider using ballasts with low RFI ratings. Shielding the ballast and the wiring can also help reduce RFI emissions. The acoustic noise produced by a fluorescent ballast can be annoying, especially in quiet environments. Some ballasts are designed to operate quietly. If you are concerned about acoustic noise, consider using ballasts with low noise ratings. Mounting the ballast on a resilient surface can also help reduce noise transmission. The energy efficiency of a fluorescent lighting system can be improved by using occupancy sensors. Occupancy sensors automatically turn off the lights when a space is unoccupied, saving energy. Occupancy sensors are particularly effective in areas that are not used continuously, such as offices, classrooms, and restrooms. The color temperature of a fluorescent lamp is a measure of the color of the light it emits. Lamps with a low color temperature emit a warm, yellowish light, while lamps with a high color temperature emit a cool, bluish light. The appropriate color temperature for a particular application depends on the desired atmosphere and the task being performed. The lumen output of a fluorescent lamp is a measure of the amount of light it emits. Lamps with a higher lumen output provide more light than lamps with a lower lumen output. The appropriate lumen output for a particular application depends on the size of the space and the desired illuminance level. The proper disposal of fluorescent lamps is important because they contain mercury, a hazardous material. Many jurisdictions have regulations regarding the disposal of fluorescent lamps. Check with your local waste management agency for information on proper disposal methods. Recycling fluorescent lamps is often the best option, as it allows the mercury and other materials to be recovered and reused.